Hi, I'm here with Deven Desai, who is a vertical lead at Planet, a company that is mapping the Earth with satellites. He's here to share a bit about data that can be gathered by satellites and how it may be applied in finance and in other industries. So Deven, what do you and your team do at Planet?
Hey, Eddie. Planet's missions are to image the Earth on a daily basis and to make it queryable or searchable. The first mission was achieved recently in 2017 by building and deploying over 300 satellites to image the globe. Once our team and partners reach this milestone, our focus has been on getting our data out there to the hands of those who can make good and productive use of it. My team focuses on creating solutions for industries from agriculture, defense, energy, and beyond to take advantage of this vast amount of remote sensing data.
Cool. So what is geospatial and remote sensing data? And what are some applications of this data?
Sure. Geospatial data is a broad term used to describe terrestrial or geographic data sets. This can include attributes such as location, which is normally represented by latitude or longitude, the types of visible and non-visible wavelengths, such as red, green, blue, or infrared. Additional attributes of the data are resolution, which is the amount of area that's covered by each pixel in the image, the level of processing done to the data, and how closely that data matches to ground truth. The simplest of examples is mapping, because it takes an army of cartographers and geographic information systems professionals, also known as GIS professionals, around the world to keep maps up to date for both offline and online use. These maps can either be raster-based, meaning there are static pixels representing a particular projection, or vector-based, meaning that there are mathematically defined series of line segments and shapes that don't really have any zoom or projection limitations. So the best way to think about this is raster-based images. If you zoom in, it will start to look blurry and pixelated. On the other hand, vector-based images, it will still look crisp and clear. Digital maps are incredibly hard to make and maintain, and services like Google Maps, Bing Maps, Here Maps have made a considerable contribution to improving their usability for GPS navigation, localization, or finding that food truck that everyone's been talking about. More uniquely, depending on how satellite imagery is structured, whether it's just the visible spectrum or includes non-visible wavelengths, determines how it can be used. For example, the images can be used to analyze the health of crops for the agricultural industry. Remote sensing data can help us understand better the current and potential future states of many of the staple crops around the world. Another example is detecting road construction. Detecting road construction for the upstream oil and gas industry is quite important, since new roads are built almost every week in areas like the Permian Basin in the US, and no one has digitized all of them. It's literally uncharted territory, and this gives information and context to do better supply chain logistics, quicker transport of crews, and also provides economic indicators of exploration activity. A similar analysis can also quantify the growth of a city so that civil government agencies that are allocating precious resources throughout a region can do a much better job.
Wow, there are quite a lot of use cases for geospatial data. How can it be used for alpha generation, and what asset classes are a better fit for this kind of data?
Yeah, generating alpha from geospatial data takes a few steps. You can't just take a look at a photo of something and then make a buy or sell call on a particular security. The industry context is quite heavy, and it's required before you can make a kind of recommendation. So far, the asset classes that benefit most from satellite data analyses tend to revolve around commodities, primarily grain futures as well as oil futures. Grain futures, on one hand, can be much better understood with proper time series analysis. Beyond just helping to create better trading decisions, this information helps to greatly identify the state of food security for a variety of nations around the world. This information also helps to identify gaps in a market, which in turn can lead to a much more faster and accurate adjustment on price for a particular grain. Also, monitoring crop health over the course of a growing cycle just leads to a better judgment on the pricing of crop futures as well. For energy commodities, understanding oil storage capacity leads to a better judgment on the movement of crude oil futures. Remote sensing and satellite data analysis, it's still a growing space, and there are a variety of image analytics companies developing solutions for various industries, including finance and insurance, as well as energy and supply chain sectors. For instance, banking and insurance companies may use satellite images to assess crop damage, forest fires, or floods, or to just improve property insurance pricing.
Sounds like geospatial data has a lot of business applications. What are some skills and techniques that are needed for analyzing geospatial and satellite data?
Yeah, the first thing to do is to understand how remote sensing data is produced. For example, once a satellite takes a photo and it gets downlinked via ground station to storage, that image still needs to have a lot of post-processing work done to it, so that it ensures that it locks the right location on the ground, that the data hasn't been corrupted, and that derivative products get produced properly for specific customer needs, among many other things. Secondly, there are widely used tools like QGIS. It's an open source geographic information system tool, or ArcGIS, which is a similar application created by the company Esri. These tools can also help non-software engineers perform similar analysis on a variety of geospatial datasets. The more technical experience you have, frankly, the better prepared you are to analyze and eventually make a more educated decision. Recent advancements in machine learning or even distributed computing made it much easier to run large-scale statistical analysis. In particular, engineers at Planet have looked at a variety of neural network architectures. Convolutional neural networks, also called CNNs, are used for computer vision, while recurrent neural networks, also called RNNs, are used for studying a time series. The cool thing is that satellite imagery data consists of a time series component. We look at neural network architectures that can combine both of these types of networks. Mainly, the industry has focused on the concept of spatial resolution, as in the amount of pixels represented in an area on the ground, something like 3 meters per pixel. Additionally, think of the different wavelength measurements that we talked about earlier, also called spectral bands, as their own feature as well. That is known as radiometric resolution. There is also the issue of temporal resolution. When a satellite gathers data on a particular location of the Earth, depending on the orbit configuration and the fleet size, it can take as little as a half a day to 14 days to collect another image. Temporal resolution refers to the frequency at which we can gather data for that same location. Unfortunately, it's been a concept for a long time, but until recently, it wasn't given much attention. So timestamps on that data point are a key feature in remote sensing as well. All of this is to say that remote sensing data is best analyzed in a spatio-temporal manner. In other words, both space and time. And this makes analyzing remote sensing data both complex and also quite fascinating.
So it seems like remote sensing data is quite unique, and it helps to build up domain knowledge to really understand how to build machine learning models using this data. How do you see the new datasets making a difference in investment analysis? And also, why is geospatial data and machine learning important in analyzing certain industries, such as agriculture and energy?
Yeah, in terms of investment analysis, the biggest advantage that's surfaced in the last few years is the sheer volume of data generated on a daily basis. This creates a double-edged sword, though, because you have so much data and sifting through it takes a lot of time. Proper data collection and annotation techniques will lead to a cleaner and more succinct training data. Proper understanding of the problem statement will also make it easier to build an appropriate machine learning model. This will lead to a faster, more statistically significant analysis. By this, I mean depending on that business problem your model is being built to solve, you may be more or less sensitive to false positives or false negatives. Or you may be requiring accuracy in some use cases. Or maybe you're concerned with the speed at which you can get an approximate answer for that buy or sell decision. So let's dive a little deeper into the energy sector. Let's say I want to detect oil well pads or road construction for a particular sedimentary basin. If I'm doing this for a mineral management company that wishes to acquire land at the right prices, I may be willing to tolerate some false positives in the model. On the other hand, if I'm building a model for an oil field services company, they would rely on the well pad and road data to get their fleets safely from one pad location to another. So they would require much higher accuracy and would be way less tolerant to false positives. This is why domain knowledge is very important. Depending on the problem, the nuance and context will help you build an appropriate model, which properly balances the trade-offs between accuracy, training time, compute time, and all the parameter modifications, among many other design choices.
That makes sense for the context and business purpose to inform the way the model is designed, and it really helps to build domain knowledge by getting familiar with the data. So what are some resources that you'd recommend for those who want to get some hands-on practice with geospatial data?
Yeah, there are a variety of resources online to better understand the tooling and importance of these datasets. There are free but somewhat coarser resolution datasets from both NASA and the European Space Agency, also known as ESA, that are available to the public. Finally, there are open source libraries like RoboSat and RasterVision that can help you quickly prototype certain analytics. Planet offers a free trial to view all of our imagery for a limited time, along with a variety of tutorials in our Developer Center to help folks get started.
Great. Thanks so much for sharing your insights about geospatial and remote sensing data.
You're welcome. It's been a pleasure to be here.